Hey, this is a quick video just to show you basically how to get started in the anti-granular TikTok pet arena capture the flag competition. So when you first logged in, you might have a slightly different screen than this. You need to click what was up here, the card up here, and fill in your details just because the competition is restricted to participants in basically Europe, so the EU, Switzerland, UK, etc. And it will just ask some preliminary questions and that you agree to the terms and conditions. When that is done, there's a manual process on the TikTok side just to approve people, but usually that takes a couple of hours or something like that, and you'll get an email in to say you're good to go for the competition. Now there's a lot of write-up in terms of the details of the competition and the quick start, but just step one, how do you actually connect and try to solve problems? Well, the first thing you need to do is just go over to this quick start tab, and you'll see the second thing, download the SDK. When you click on that, you download a zip, and when you unzip it, and you open it in your favorite IDE, you'll get something that looks like this. If you've done this like earlier in the competition, the SDK file has changed slightly, so you might want to do it again, and it just makes the connection slightly easier. So I've opened up the demo, demo Jupyter Notebook. What we're going to do is just connect. So we want to connect to the server, be able to ask SQL queries, like ask questions, get back results, and then from those results try to infer things, i.e. try to predict or guess membership, etc., information about groups. So the first thing we need to do is we come back over to the anti-granular portal, and if you can see where my mouse is, we're just going to hit the copy button. That's our credentials, and we're going to go to the first cell. So from SDK, import create config, and in that create config, we're just going to paste is our client ID and client secret. If our video editor is any good, she will have blurred out those details, so you can't use mine. And when we run that cell, it's created this local folder for us, and it's basically created the credentials. So it's going to use those credentials going forward, so that when we speak to TikTok's backend, it will act on our behalf. So now that we've got that done, we can start importing from the SDK, the load config, the SQL query client, which is like the main thing that we're going to submit our SQL queries to, and then some helpers like get credentials, etc. Loading config will just load the details from the config we previously created. Done. And now we can create a SQL query client to actually make some queries. Before doing so, when we're making connections, we need to say which mission we're doing. So there's 5 missions and there's 3 tracks. So if we go back here, the details of them are in the details page. First mission is a statistical inference. So infer the highest compensation for millennials, infer co-workers membership in a book club, detect book club members and their attributes, salary inference through cross data set linkage, and then open-ended attacks only available to participants with at least 100 points, and then your total score is out of 1,250. So they're the 5 missions, and then there's 3 tracks. The first track basically has no output disclosure controls, so you can make queries and it will give you the exact results. Right, that's great. So that might be the easiest thing to initially attack. The only thing I would say with that is using those results for track B and track C will be no good, because for the winners you actually have to submit the notebooks you used as well. So you want to show how you actually achieved it too. Track B is going to be more of a classic anti-granular type competition. So in this one, you're asking queries, and it's using zero concentrate DP, which means it's applying a little bit of Gaussian noise to all of your results, and that Gaussian noise is parameterized by a row of 0.01 for all Gaussian mechanism queries. And it talks about how that's going to compound. And in track C, it's like opaque, so they don't tell you the full details. It's kind of like a black box, so they're basically going to be using noise mechanisms for differential privacy, but the parameters, the query restrictions, the privacy budget tracking, etc. are more opaque. So you can think of track A, B, and C as like easy, medium, hard to try to solve these missions. And then for each of the missions, you're trying to learn a different thing, basically. So when we're making a connection in, we set our mission, let's say mission 1, and track B. So this is with differential privacy, and mission 1, I think, was working out the salary of millennials, fair the highest compensation of millennials. So if we do that, we have a client, which means we can start making SQL queries. Now, obviously, as we're making queries, we're asking for different feedback. You know, we're asking for we're asking their backend to give us a result, and that is consuming some privacy budget on each query. So if we want to know how much budget we've spent so far, it will tell us. At this point, we've made no queries on any on track A, B, or C. The budget hasn't been used, etc. And so, like, once we start making queries, these numbers will of course increase. If we want to make our first query, this is a single query example. So they've provided some helper functions like a single query example, and you could just write your SQL query here. But you can see the main thing is they're just taking the SQL client, they're submitting the query. You can get query budget. So this is the budget is not disclosed for C, for track C, but for B, you'll obviously get your budget. And then when it completes, they can be a little bit slow to run, by the way, that's just a heads up. When it completes, then you'll get back in CSV format the result. So that will print it to screen, but I mean, you could change the code if you want to like save it into an array or write it to a file or whatever. So let's just run this. Select count distinct user IDs as detection UV from test table. So the budget consumed, as they said in the overview, is 0.01 under row for zero concentrate DP. It's executing it. It does, each query is taking, I've noticed, about 40 seconds to run. So just good to know. If you're running like loads of queries and you're thinking, are things taking a while or something? Yeah, that's the back end that they provided. So just know that that's normal. 38 seconds, 40 wasn't too far off. And great, so the result is 1000.737581, blah, 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 blah. Now you might think, well, if I'm counting distinct things, the result should be an integer, but of course they've added floating point noise, essentially, to that number. So we're seeing 1000, but maybe it's 996 or 1012 or whatnot, and that noise has shifted the result that we're getting back based on it being greater than or less than the true result. It's the randomized noise that helps provide output privacy, or differential privacy. They've also given examples where you can batch queries, so you can write a whole bunch of queries, they will execute one after another. They each take about that 40 seconds. So if you have like, I don't know, say in some challenge you have like 30 queries that you want to execute, that might take 20 minutes or something. So maybe you want to hit run and then go make yourself a coffee, come back, see the progress, etc. One thing that they've also done is they automatically, in their SDK file, they prevent you from accidentally spending budget too many times. So if you ask the same question again, instead of going and executing it, it will just cache the result. It like hashes the query, and then it remembers the result that it got, and then just feeds that back to you, so you're not spending budget like accidentally. In fact, if you want to see that, inside of local, you're going to see cache, and it's from your mission 1 track B, and you can see the SQL job, that was the job that was created based on the SQL here that we made. It got a job ID, this is the FOB, blah, 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 blah. And then from the IDs to results, this is the ID that was the query ID. The result was then success, and you can see it's in CSV. So it's got the column name, \n, and then the result \n, because if it was a table, for example, it would be CSV formatted. So that's in your cache. So hopefully that's pretty much it, to be honest. The only thing is, of course, when it comes to submitting results, but given time, I think I'll leave that for the next video. Great, happy competing and writing your SQL queries.